This is for Year 11 methods, and it's the algebra to find axial intercepts and equations, and also sketching for a variety of different circles. Okay, in this first example, x plus 1 all squared plus y minus 4 all squared minus 169 equals 0. Remembering that x squared plus y squared equals the radius squared, I'm going to pop this negative 169 to the other side. X plus 1 squared plus y minus 4 squared equals 169. Therefore, the centre of the circle is at negative 1, 4, has a radius of the square root of 169, which is 13. So, of my circle, it's got negative 1 and 4 is where the centre is. The top's going to be 13 above there, up at 17. The bottom's going to be 13 below at negative 9. This is at negative 1, so 13 across at 12 and 13 across at negative 14. So there's my circle. And I know that it has radius of 13. Okay, how do I find the x and y intercepts? The x-intercept, let y equal to 0. So x plus 1 squared plus 16 equals 169. 0, negative 4 all squared is positive 16. X plus 1 equals 169 minus 16, which equals 153. X plus 1 all squared. Take the square root of both sides. X plus 1 equals plus or minus the square root of 153. Therefore, x equals minus 1 plus or minus the square root of 153. So the coordinate there is minus 1 plus the square root of 153. And the x coordinate there is minus 1 minus the square root of 153. To find the y-intercept, that's where we let x equal to 0. So I'll have 1 squared plus y minus 4 all squared equals 169. 1 plus y minus 4 all squared equals 169. Y minus 4 all squared equals 168. Y minus 4 will equal plus or minus the square root of 168. Okay. 168 times 1, 84 times 2, 42 times 4. So it's going to be 2 root 42. With 42, 4 doesn't go into it, 9 doesn't go into it. Can't simplify that, so I'm just going to leave that as y equals 4 plus or minus 2 root 42, which means that coordinate there is 4 plus 2 root 42, and that there is 4 minus 2 root 42. Example number 2 looks like this. In the form, where does 2x minus 3 equal 0, 2x equals 3, x equals 3 on 2, 2y minus 5 equals 0, 2y equals 5, y equals 5 on 2. Therefore, this is the circle that is centred at 3 on 2, 5 on 2, and has a radius of the square root of 36 or 6. So I know that it's centred at 3 on 2, 5 on 2, and it's over here at 6 minus 6 plus 6 minus 6. So I know that the circle follows that particular shape. Now how do I find these x and y intercepts? Same process to find x and y intercepts is to find the y-intercept, let x equal to 0. So 9 plus 2y minus 5 all squared equals 36. 2y minus 5 all squared equals 36 minus 9, or 27. 2y minus 5 equals the square root of 27, which is 9 times 3, so that's equal to 3 root 3. And there are two answers when you take the square root, plus or minus. So 2y will equal 5 plus or minus 3 root 3, and y equals 5 plus or minus 3 root 3 all on 2. So the coordinate here is 5 minus 3 root 3 all on 2. And the coordinate here is 5 plus 3 root 3 all on 2 and 0. To find the x-intercept, we let y equal 0. So 2x minus 3 all squared plus 0 minus 5, so 25 equals 36. 2x minus 3 all squared equals 11, that's 36 minus 25. 2x minus 3 equals plus or minus the square root of 11. 2x equals 3 plus or minus root 11. X equals 3 plus or minus root 11 all over 2. Which means the coordinate here is 3 plus root 11 all over 2 and 0. And the coordinate here is 3 minus root 11 all over 2 and 0. So there's the circle, the x-intercepts and y-intercepts in exact form. This third example, y minus 2 equals the square root of 4 minus, if I was to square both sides, I would end up with y minus 2 all squared equals 4 minus x plus 2 all squared. And if I was to move that to the other side, I've got x plus 2 all squared plus y minus 2 all squared equals 4. I'm now in the form of a circle. So this is a circle centred at -2, 2 with a radius of 2. However, I don't have a full circle. I've only got the positive square root, which means I've only got the top half of the semicircle. So if this is at -2, 2, then this is what I'm looking at because it's got a radius of 2. And that's the extent of what I have because I've got a positive square root, so I have these positive values. I don't have the bottom half of the semicircle because even though when I did the algebra of squaring both sides, when I go backwards and I take the square root, I only have the positive square root, not the negative square root. So that's inclusive, so that's -4 and 2, that's at 0 and 2, and that's what that one looks like. Technique number 4 is pretty straightforward. It's a circle centred at -2, 0 and a radius of 5. So that will go over to there to 3, and that will go over there to -7, and I'll be able to find out what those y-intercepts are by the same process as setting y equal to 0. And in the last example, question number 5, find the equation of the circle that's centred at 2, -3, and it touches the x-axis. So I've been given some information about the circle, some key features. It's centred at 2, -3, and it just touches the x-axis. If it touches the x-axis, therefore that must be where it touches, and that's what the circle is going to look like. Which means I now know that the radius of the circle is 3. So it's going to be x minus 2 squared plus y plus 3 squared equals radius squared, which is 9. So there's the equation of that particular circle.